Dear students, today we will discuss about the cascade multi-stage amplifiers and what is the significance of cascade amplifier and what is the role of cascade amplifier in the electronics field. So resistor of each stage is coupled into the base of the next stage. So the overall gain product of the individual gain voltage from one stage to the another state. The most widely used method coupling a signal from one state to the another state and block DC. So generally we connect the one stage of the amplifier to the second stage of the amplifier by the capacitor C, that is the coupling by the capacitor C, and we also done the coupling by the resistance or capacitance, that is the RC coupling of cascade amplifier. So cascade amplifier improve the gain of the amplifier in this process, and also multi-stage amplifiers. So multi-stage amplifiers are amplifier circuits cascaded to increase gain. So with the help of multi-stage amplifier, we increase the gain of the amplifiers. We can express gain in decibel dB. So two or more amplifiers can be connected to increase the gain of an AC signals. The overall gain can be calculated by simply multiplying each gain another. So there is, in this figure, there is more than one amplifier, and these amplifiers are connected in multi-stage form. So the gain of these multi-stage amplifiers, total gain will be AB equal to product of each amplifier's gain. So here one amplifier have the gain AB1, second is one AB2, and third is AB3. So total overall gain of this multi-stage amplifier is AB equal to AB1 dot AB2 dot AB3. So total gain is the multiplication of each multi-stage amplifier's gain. So for example, we want to find out the output voltage of this figure that is given here. Suppose we have the V input voltage 5 millivolt and we have the AB1 gain of first stage amplifier 5 and second stage amplifier gain is 10 and third is 6 and next nth amplifier we have the gain of 8. So what is the total output of in this case? So gain will be the total gain will be the multiply of AB1, AB2 into AB3 and ABN. So here the gain equal to 5 multiply 10 multiply 6 and multiply 8. So this is the total gain of this example of multi-stage amplifier. And in this circuit diagram, that is the two-stage amplifier in a cascade configuration. So in this circuit diagram, there is the two amplifiers which is connected or cascaded to each other, and here the one amplifier is the Q1 and second amplifier is the Q2, and both amplifiers connected to each other by the cascade manners. And so this is the two-stage amplifier cascade configuration. We also can increase the more than two amplifier also connected in this cascade configuration form. This circuit diagram show a small signal equivalent circuit of the cascade amplifier or cascade configuration. So this is the small signal equivalent circuit of the cascade configurations. So by small signal gain, by determine the voltage gain at stage 1 and stage 2. So AB total gain equal to here AB1 into AB2. Therefore, AB equal to output voltage upon source voltage and equal to GM1 into GM2 into RC1 parallel to R by 2 into RC2 parallel to RL into Zn upon Zn plus Rs. So this is the gain of this equivalent small signal amplifier, and the gain in decibel. So we find out the gain in decibel, that is the AB in decibel equal to 20 log of gain of voltage. So here the input resistance is equal to R1 parallel to R2 and also parallel to R by 1. Here V as source voltage is equal to 0 and B pi 1 equal to B pi 2 also 0. So we have Gm1 V pi 1 equal to Gm2 V pi 2 equal to 0. Therefore, the output impedance Z out equal to RC2 parallel to RL. So this is the output impedance of this cascade amplifier. Now we draw the AC equivalent circuit and calculate the voltage gain, input resistance and output resistance for the cascade BJT amplifier in this figure. So here let the parameters are R1 equal to R3 equal to 15 kilo ohm. Here this is value given here, and R2 equal to R4, that is equal to 4.7 kilo ohm, and RC1 equal to RC2 equal to 2.2 kilo ohm, and also emitter resistance of both amplifiers RE1 is the same, that is the 1 kilo ohm. So for DC analysis, at transistor Q1, the IBQ1 equal to 19.89 microampere and ICQ1 equal to 3.979 milliamperes. And at the transistor or amplifier Q2, we have IBQ2 equal to 19.89 microampere and ICQ Q2 equal to 3.979 milliampere. So by the AC analysis at Q1, R pi 1 equal to 1.307 kilo ohm and GM equal to 0.153, and Q2 is the at the Q2 R pi 2 equal to 1.307 kilo ohm and GM equal to 0.153 S. From the AC equivalent circuit at transistor Q1, the voltage gain is AB Q1 equal to V naught Q1 upon Vi equal to minus Gm into RC1 parallel to Ri2, where V naught Q1 is the output voltage looking into the Q1 transistor and Ri2 is the input resistance looking into Q2 transistor. Therefore, Ri2 equal to Rv2 parallel to Rpi2 and equal to put the value of Rv2 and Rpi2 here. So we find out the Ri2 equal to 957.36 ohm, and also the voltage gain at the transistor Q1 is AB Q1 equal to minus 0.153 into 2.2K parallel to 957.36. So this is the gain equal to minus 102.06. So this is the voltage gain at the transistor Q1. And from the also AC equivalent circuit at transistor Q2, the voltage gain is AB Q2 equal to V naught upon VI Q2 equal to minus GM RC2, where VI Q2 is the input voltage looking into the Q2 transistor. Therefore, the voltage gain at Q2 is AB Q2 equal to 0.153 multiply 1.2 K. So this is equal to minus 336.6. This is the gain of at transistor Q2, and overall gain is then, so overall gain is the product of these two gains AB Q1 multiply AB Q2. So multiply these two, we have the overall gain is then AB equal to 34,353. This is the overall gain of this cascade amplifier. The large overall gain can be produced by multi-stage amplifiers. So the main function of cascade stage is to provide the larger overall gain. So this is the main function of the cascade stage amplifier. This provides the larger overall gain of the multi amplifiers, and we can also find the input resistance from the AC equivalent circuit. So input resistance Ri equal to R1 parallel to R2, and this is parallel to Ri1. So put the value of here R1, R2 and Ri1 and find out the value of input resistance. So we have the value of input resistance Ri equal to 957.36 ohm, and also we can calculate the value of output resistance with the help of this equivalent AC circuit. So output resistance R naught here will be equal to RC2, or that is 2.2 kilo ohm. So these are the value of input resistance and output resistance of the cascade amplifiers. The next is the multi-stage amplifier. So in the different circuit diagram given here, there is the more than one amplifier are connected to each other. So circuit diagram show first show the three-stage amplifier, three-stage cascade amplifier, and second one show the two-stage cascade amplifier, and also circuit diagram 3 is also show the two-stage cascade amplifier. So these are the different circuit diagram of the different multi-stage amplifiers in which their different transistors are used and different value of other components also given here. And so these circuit diagrams show the different multi-stage amplifier circuit diagram. So next, what is the multi-stage amplifiers? So what is the multi-stage amplifier? What is the important terms? Circuit diagram, working, frequency response, and what is the advantage and disadvantage of multi-stage amplifiers? So amplifier is the electronics device which amplify the signal voltage and signal currents. And also there are different types of amplifiers. So vacuum tube amplifiers, transistor amplifier, multi-stage amplifier, operational amplifier also. So there are different types of multi-stage amplifiers, and actually the picture view of the different amplifiers here given in this slides also. So multi-stage amplifier, a transistor circuit in which number of amplifier stages are cascaded or one after another in series. So this is multi-stage amplifier. And coupling device, so device which connect the output of one stage to the input to the next stage. So that is the coupling device. And for the coupling device we use resistance and capacitance also. So we can coupling with the help of RC, and we connect the output of one stage to the input to the next stage by the help of RC networks or RC coupling device. So depending on the manner in which the different amplifier stages are connected, one of the following amplifiers may be result. First one is the RC coupled amplifier and also RL coupled amplifiers. So there is the first stage, and next one is the coupling device and connected to the second stage, and next again coupling device and connected to the third stage. So between two stage of amplifier, there is a coupling device between these two amplifiers. So there are different multi-stage amplifier given here. The circuit diagram of the different multi-stage amplifier, as we can see in these diagrams. So first circuit diagram show the cascade RC coupling multi-stage amplifier. Second one is the cascade multi-stage amplifier. Third one is the transforming coupling. So we also couple the one stage of amplifier to the next stage of the amplifier with the help of transformer. So this type of coupling is the transformer coupling. Next one is the in circuit diagram fourth, that is the Darlington or direct coupling method for the multi-stage amplifier. So there are different examples of the multi-stage amplifier in the circuit diagram and different cascading coupling methods here. So what is the function of coupling device? To transfer any AC output of first stage to the input of next stage. So this is the function of coupling device, that transfer only AC output of first stage to the input of next stage. And multi-stage amplifier cascade connection output of one stage to connected to the input of another stage in this circuit diagram. So here total two amplifiers. Amplifiers one have the gain of AV1 and have the input voltage VN1 and output voltage V01. And also here second amplifier which have the gain AB2 and output voltage is V02 and input voltage is for this amplifier is V01. So here we can calculate the overall gain of this multi-stage amplifier. So here overall gain AB will be B0 2 upon V input 1 equal to AB1 multiply AB2. So this is the gain product of two amplifiers gain, that is the AB1 and AB2. So overall gain AB will be equal to here AB1 multiply AB2. There are also some important terms related to multi-stage amplifier. So first term is the gain. So what is the gain? The ratio of output to input of an amplifier is the gain. And gain is generally represented by G or A. So in this multi-stage amplifier, here first stage, second stage and third stage also connected to each other, and they have the different gains of different amplifiers here. So if input signal is B input, then output of the first stage output of G2 V in, and second stage output G3 V in, and output of third stage G1, G2, G3, and So overall gain of this multi-stage amplifier is the V output upon V input equal to G1, G2, G3, G4 and so on. So this is the product of gains of different amplifiers. That is the overall total gain of this multi-stage cascade amplifier. Next term is the frequency response. So frequency response is the curve plotted between voltage gain versus frequency. So we take the voltage gain on y-axis and frequency on the x-axis. So there is the bandwidth. We can also find out the bandwidth of this frequency response. So bandwidth is the upper frequency FH minus lower frequency FL. So bandwidth is the difference of two frequencies, that is the FH minus FL, equal to bandwidth of this frequency response. So upper high frequency minus lower frequency. So this is the frequency response of the multi-stage amplifier. And with the help of frequency response, we find out the bandwidth of this multi-stage amplifier. And what is the bandwidth? So bandwidth, the range of frequency over which gain of the amplifier is equal to or greater than 0.707 or 70.7% of the maximum gain. So this is the bandwidth, and here in this figure there is the graph between gain versus frequency, and we here also find out the bandwidth of this graph. So next one is the noise. So noise measure of undesired noise mixed into the output. So basically noise is the unwanted signals that create the interference in any signals. So this is the also circuit diagram of two-stage multi-stage amplifier. So in this circuit diagram, the coupling is done by the capacitor. So this is the two-stage capacitor coupling cascade amplifiers. Here is also two transistors. One is stage first and second transistor in stage 2. So both stages are connected by the coupling of capacitor. So this is the also show the circuit diagram of two-stage capacitor coupling amplifier. Here in this circuit diagram, the R1, R2, R3 and R4 form the biasing and stabilization network in this circuit diagram also. Input capacitor C input couples the AC voltage to the input. So for input supply, that is the AC voltage, is coupled by the capacitor, input capacitor, and the capacitor CE, known as the emitter bypass capacitor in this circuit diagram, used to offer low impedance to the AC signals. The coupling capacitor CD couples the output of first stage of the input of the second stage, since the coupling capacitor passes only AC signal and block the DC. So we have also know the capacitor is pass the AC signals and block the DC signal also. So DC, that is by coupling capacitor called blocking capacitor. So this is capacitor is called as a blocking capacitor because this capacitor block the DC supply and pass the AC supply. So it is called blocking capacitor. The overall gain is less than the product of gain of individual stage. So the second stage is made to follow the first stage. The effective load resistance of first stage is reduced because of the input resistance of second stage is reduced overall gain of the output. So in frequency response of the coupled amplifier, so frequency response curve plotted between frequency versus gain. So if case first, in case first, when frequency less than 50 Hz, so gain falls. A part of AC output of first stage is low, capacitor CD, which offer very high reactance at very low frequency, because at very low frequency, common emitter bypass offer high reactance and could not shut the emitter resistance RE. So here XC equal to capacitor impedance equal to 1 upon 2 pi FC. In case second, beta transistor parameter, so at very high frequency, the reactance of CC become very small and it behave as a short circuit. In case third, mid frequency range 50 between 50 kilohertz to 50 hertz, gain constant in this frequency range. So frequency increase reactance of CC decrease, which increase the voltage gain, decrease in reactance, producing higher loading effect of first stage, which decrease the gain. And what is the advantage of multi-stage amplifier? So it has lower cost since it employs resistor and capacitor, which are very cheap. It has excellent frequency response. The gain over the audio frequency range, which is the region of most important speech, music, etc. Third one is the circuit is very compact, as the modern resistors and capacitors are small and extremely light. So these are the some advantages. And also there are some disadvantage here. They have the tendency to become noisy with age, particular in moist climates. The RC coupled amplifier have low voltage and power gain. So this is the Also disadvantage of RC coupled amplifier. And third one is the impedance matching is very poor. So because the output impedance of RC coupled amplifier is several hundreds ohm, whenever input impedance is only a few ohms. So hence little power will be transferred to the speaker. So impedance matching is very poor. And applications, the RC coupled amplifier have excellent uh, over a wide range of frequency. Therefore, they have widely used as a voltage amplifier. So this is the actually photographs of RC coupled amplifiers. This is the kit for the multi-stage amplifier circuit. Reference books for this topic. The electronics device and circuit by the Millman and Halkias is cover this topic. So we can use this book for as a reference book. There are some multi-choice question, and that is the very important for clear the concept of topics. So here question first, an important characteristics of the CMOS circuit is the option A, noise immunity, option B, duality, option C, symmetricity, option D, noise margin. So here the correct answer is for the characteristics of the CMOS circuit is it have duality. So this is the property of CMOS circuit which have the duality characteristics. So option B is correct answer. In next questions, CMOS logic dissipates power than NMOS logic circuits. So option A more, option B less, option C equal, and option D very high. So here correct option is B because CMOS logic dissipate less power than NMOS logic circuit. So dissipation of the power in the CMOS is less as compared to the dissipation power in the NMOS logic circuits. In next questions, semiconductors are made of option A, germanium and silicon, option B, silicon and lead, option C, germanium and lead, and option D, lead and AU. So generally semiconductors made of germanium and silicon. So here correct option is A, semiconductors are made of silicon and germanium. In next question, CMOS technology is used in option A inverter, option B microprocessor, option C digital logic, option D both microprocessor and digital logics. So here correct answer is option D, because CMOS technology is used in both microprocessor and digital logic circuits. So correct answer is option D. Next, two important characteristics of CMOS device are the two important characteristics of CMOS device are. First one is high noise immunity. Second one is low static power consumption. Option C, high resistivity. Option D, both high noise immunity and low static power consumption. So correct answer is the here option D. The two important characteristics of the CMOS device are, first one is it has high noise immunity, and second important characteristics of CMOS device is it have low static power consumption. So these are the two most important characteristics of the CMOS device. Next one is CMOS behave as an adder, subtractor, inverter, comparator. So CMOS we have as an correct option is here inverter. So CMOS we have as a inverter. The next, the full form of CMOS is option A, capacitive metal oxide semiconductor. Option B, capacitive metallic oxide semiconductor. Option C, complementary metal oxide semiconductor. Option D, complemented metal oxide semiconductor. So here in this question, the full form of CMOS is the complementary metal oxide semiconductor. So here correct option is C, complementary, C for complementary, M for metal, O for oxide, and S for semiconductor. Complementary metal oxide semiconductor. In next, the full form of cosmos is. The full form of cosmos is. So here option A, complementary symmetry metal oxide semiconductor. Option B, complementary systematic metal oxide semiconductor. Option C, capacitive symmetry metal oxide semiconductor. Option D, complemented systematic metal oxide semiconductor. So here the full form of cosmos is. So correct answer is option A, C for complementary, O for complementary, COS, complementary symmetry metal oxide semiconductor. So correct option is A, C, osmosis. complementary symmetry metal oxide semiconductor. And next question. CMOS is sometimes referred to as option A, capacitive metal oxide semiconductor, option B, capacitive symmetry metal oxide semiconductor, option C, complementary symmetry metal oxide semiconductor, option D, complemented symmetry metal oxide semiconductor. So CMOS is also sometimes referred to as, here option C, complementary symmetry metal oxide semiconductor. So sometimes referred CMOS. Basically full form of CMOS is the complementary metal oxide semiconductor. What sometimes CMOS is also referred to as complementary symmetry metal oxide semiconductor and also Cosmos. So they are the some multi-choice questions. Thank you. Thank you very much.